Welcome back, guys. Welcome back to my channel. This is my third video. Before two videos, one was of CMA 2018 UGB, which is the second paper. The next one was a USMO question, the US Mathematical Olympiad question. Both are based on polynomials. Today's question is an interesting one. I was just looking back through one of my papers and found this. It has come in up here as 2022 UGB, that is the second paper. This question, this mod of sin x plus cos x plus tan x plus cot x plus sec x plus cosec x. We need to find the minimum value. So this question covers two concepts. Actually, if possible, it is a nice question covering two or three concepts. One is your trigo. Number two is poly. And number three is maximum minimum. Interesting question. Let's get down to solving it. Solve. Just a second. I will be changing my color to black. Yeah. So what do I have here? Mod of sin x plus cos x plus tan x plus cot x, tan x plus cot x plus sec x plus cosec x. I'll be considering this to be your mod of f of x, that is a function of x. So this is basically your, from here, f of x is equals to sin x plus cos x plus tan x can be written as your sin x by cos x plus cot x can be written as your cos x by sin x. Now sec x can be written as 1 by cos x and cos x can be written as 1 by sin x. If we add this, then it will be sin x plus cos x plus the here it will be having your LCM as your sin x cos x, and there comes your cos x. So we will be taking the LCM cos x and its sin x to complete its multiplication of sin x cos x. So sin x into sin x, which is a sin square x, plus cos x into cos x, which is a cos square x. So this is basically your sin square x plus cos square x plus sin x cos x and up it will be your sin x plus cos x. It will be sin x plus cos x as usual. This is getting continued the same. So sin square x plus cos square x by trigonometrical identities is 1. So 1 by sin x cos x plus sin x plus cos x by the sin x cos x. So what will I be doing here? I have my sin x plus cos x, here also sin x cos x. This is my complete trigonometrical expression is considering of, it is consisting of sin x plus cos x and sin x cos x. So what will I do? I will be taking my sin x plus cos x to be your t. Suppose let I can whole square them. So giving me the whole square would be your sin x plus cos x whole square is equals to t square. So sin x plus cos x whole square is basically sin square x plus cos square x plus 2 sin x cos x, and sin square x plus cos square x, as we know from trigonometrical identities, is 1. So this is 1 plus 2 sin x cos x to t square. We separate our sin x cos x here. Sin x cos x is equals to t square minus 1 by 2. Sorry for this. T square minus 1 by 2. So if we from here, so what are we getting? Sin x plus cos x we have taken to be t plus 1 by sin x cos x is 1 by t square minus 1 by 2 plus sin x plus cos x by sin x cos x. So there's your t by t square minus 1 by 2. There's your t. Just a second. Yeah, t by t square minus 1 by 2. So now, if you simplify this, this is an expression in t, polynomial in t. So t plus, yeah. So t plus, I will be taking my 2 in the numerator. So 2 by t square minus 1 plus 2t by t square minus 1. So this is basically your t plus, I will be taking my 2 common. So that is your 2 into t plus 1. This is t by t square minus 1. So this can be your 2 plus, I mean t plus 2 into t plus 1, and my denominator is t square minus 1, which can be factorized as t plus 1 into t minus 1. So this is my t plus 1 and t plus 1 is getting cancelled. So ultimately my f of t is equals to t plus 2 by t minus 1. So therefore my f of x has become my f of t. We need to find max min of f of t. So yeah, f of t is your t plus t minus 1. So I'll be taking my LCM to be your t minus 1, or probably I won't be taking the LCM. I'll be, now here comes a new concept. So we have my f of t to be your t plus 2 by t minus 1. The concept is that of maximum minimum. What is it? So now what is this? In class 11 and 12, there is a chapter differentiation in which we are required to sometimes find the maximum and the minimum value of various functions. How do we do it? Very simple. First of all, what we'll be doing is, though it depends upon the degree of the polynomial, but still then, first of all, for every type of polynomial, the basic step would be to differentiate the polynomial once. We'll be doing this. Step 1, differentiate the polynomial. Step 2, make it equal to 0. Make it equal to 0. And find the unknown. Find the unknown. So here my f of t is your t plus 2 by t minus 1. It is your t plus 2 by t minus 1. Now I will be doing is f dash of t is your 1. So how do we differentiate this function? This can be written as your 2 into t minus 1 whole to the minus 1, which is here. I'll be differentiating this, which is a v du by dx. V du by dx is basically your 0, because the differentiation of 2 is 0, and minus u dv by dx. Minus u dv by dx is your minus 2 by t minus 1 whole square. We need this to be 0. Now what I can do is take this to the LHS and just rearrange my signs. We should be your t2 by t minus 1 whole square is 1. From here I can be writing as t minus 1 whole square is equals to 2. Then t minus 1 will be your plus or minus root 2. So t is your plus minus root 2 plus 1. I'm getting my value of t, which is 2. That is, we are getting two values of t. Now this has a very high significance. Two values of t. Why two values of t? Because within these two values of t's, for one t we will be having the maxima, and for another t we will be having the minima. Now this can be calculated by double differentiating the function which we are given earlier, but since it is a trig function, that is a trigonometrical function, always for trigonometrical function always check domain. This is very important. Always check the domain. Now for domain checking, what we'll be doing, first of all I'll be taking a different color. Now here is domain check. This is an important step. Now t is equals to sin x plus cos x. Maximum value of sin x is 1, maximum value of cos x is 1, minimum value is your minus 1, minimum value is minus 1. So max t will only be possible when both the functions separately have their maximum values, that is 2, and min t will only be possible when they have their minimum values, that is minus 2. Here we are given two values of t. Two values of t, which is your plus minus root 2 plus 1. So this basically two values, one is your root 2 plus 1 and another is your minus root 2 plus 1. Root 2 plus 1, so root 2 is 1.414 plus 1, which is your 2.414, and minus root 2 plus 1 is your minus 1.414 plus 1, which is your minus 0.414. Now from here, what have I said? The maximum value t can take is to be 2, where each sin x and cos x will be having the maximum values separately, that is 1 and 1. But this value 2.414 is greater than 2, hence not possible. Since out of range. Important check, a very important check. So hence we are left with only one value. Left with one value of t, which is your minus root 2 plus 1, that is your minus 1.414 plus 1, which is a minus 0.414. So this is your t. Now what do we need to do? We need to find out what is f of t. What have we got our f of t? F of t is basically t plus 2 by t minus 1. F t is your t plus 2 by t minus 1. Sorry. If you put f of minus root 2 plus 1, what do we get up here? Minus root 2 plus 1 plus, I will putting this in brackets, plus 2 by minus root 2 plus 1 minus 1. My 1 and 1 gets cancelled. 1 minus 1. What are we left with? Minus root 2 plus 1 plus 2 by minus root 2. My 2 is basically root 2 into root 2. So my root 2 and 2 gets cancelled. We are left with root 2, that is minus root 2. So ultimately what do we get up here? It's a minus 2 root 2 plus 1. Ultimately, f of t is basically your minus 2 root 2 plus 1. So this is my final answer. We had been talking about the minimum value. So this is my minimum value. The real numbers x naught multiple of 5 by 2. So this came in ISI 22 UGB. Very cool question consisting of three concepts which have been intermixed very well with each other. One is trigonometry, that is the play of sin x and cos x. The next one is polynomial, that how we form the f of t from f of x. The third one is maximum minimum, where we differentiate the function. Very important concept. So what have we learnt up here? A very important concept of maximum minima, where we differentiate the function to find out the values of t for which the function might take either maxima or minima, and manipulation of trigonometrical functions in some very cool ways. Also, ultimately, my answer is here minus 2 to plus 1. This question had come in ISI 22 UGB, that is the second paper. It was most probably either of 8 marks or of 10 marks. I just forgot the marking, but it was either of 8 marks or 10 marks. A very good question and a solvable question, just a little bit of trickery and a little bit of brain is needed. So yeah, this was for today. Thank you. Do subscribe and like my videos. Bye.